Following Unit 1, we will start now with Unit 2. Unit 2 will be dedicated to talk about the typology and activity of agrochemicals. Rather than an extensive and detailed explanation, I will give an overview of the different ways that pesticides are classified, thus complementing the information that I gave in Unit 1 that was mainly focused on defining the discipline of study that is ecotoxicology from a historical point of view. Let's start by explaining or asking ourselves, what is a pesticide? We could think that the pesticide is a killer of pests, but not only those compounds that may kill pests are considered pesticides, but also the chemicals tools used to manage all kinds of pests, and any substance used for controlling, preventing, destroying, or repelling or mitigating any pest. This table shows the major types of pesticide and their chronology of development. As we have already said, the beginning of the development of pesticides in the 19th century was using very toxic compounds. In the 1950s, there was the first use of organochlorines, then moved to organophosphates and carbamides, synthetic pyrethroids, and then the further developments were dedicated to find genetically engineered organisms, biopesticides, natural predators, and then later on was more focused on finding other ways of producing in a more integrated way, like integrated pest management, or for instance also the organic agriculture. We were talking about organochlorines. Organochlorines are also called chlorinated hydrocarbons, discovered in 1940s and 50s, are mainly insecticides, and there are three main groups. When we talk about organophosphates, we are referring to organic esters of phosphorus acid. Those are also used as insecticides, and the action is like organochlorines that act as neurotoxin. Carbamates are derivatives of carbamic acid, also used as insecticides, but also as molluscicides, nematicides, herbicides, and fungicides, have a similar mode of action than the compounds that I was referring before, organochlorines or organophosphates, and in this case are considered to be not accumulative, that are regarded as representing more a short-term hazard than a long-term hazard that was associated to other pesticides. Pyrethroids were synthetic compounds similar to the pyrethrins of chrysanthemum. They are also neurotoxic but more biodegradable, even though when they are bind to particles in salts and sediments, they could become persistent. They are also mainly used as insecticides, and there is some concern over the effects that may have on non-target invertebrates. They have been extensively used, and there have been also different generations aiming each one of the new generations to be more active and then being applied in the different generations at lower concentrations. The last group of pesticides that have been developed, which are also insecticides with a similar mode of action, and the ones that I have been talking about, are the neonicotinoids. The neonicotinoids that were produced by Shell in 1980s and Bayer in 1990s. They were supposed to be much better compared to organophosphates and carbamate insecticides because they are less toxic to in general birds, mammals, and so on. However, it has also been seen that they may influence wildlife. More specifically, they may influence honeybees, and this is an important issue considering the interest that honeybees have for the wildlife in general, but also for agriculture. And it was for the reason that in 2013, the European Union and a few non-EU countries restricted the use of some of the neonicotinoids, the ones that it was shown that were more toxic for the environment. Then the use of pesticides has moved to integrated pest management. This is a scientific approach to agricultural problems that is combining a limited use of pesticides, which should be more friendly to the environment, with a better pest management, targeted application, and education of farmers and environmental awarenesses. In fact, according to the FAO, integrated management means the careful consideration of all available pest control techniques and the subsequent integration of appropriate measures that discourage the development of pest populations and keep pesticides and other interventions to levels that are economically viable and that reduce or minimize risks to human health and environment. In fact, IPM, as you all may know, has been implemented in Cambodia. One of the alternatives to the use of pesticides is the agricultural or the organic agriculture, which has been developed in the last 30 years. It has been able to provide 3 to 4% of food and beverage as organic agriculture, and up to 11% of fruit and vegetables is organic in the USA, or was organic in 2009. However, those numbers are small. Then, Algarve Organic Agriculture started as an environmental movement to reverse the problem of pesticide residue of conventional agriculture and to protect the ecosystem. As we all know, it is very limited and it cannot solve the difficulties that we have for food production worldwide. Going back to the table that I have shown at the beginning, where it was described the chronology of pesticides, this change over time is also related with reduction in terms of health effects on humans, more specifically on the farmers, and also on environmental effects. While the first pesticides were very toxic to humans and caused huge effects on the environment, toxicity was lower in the ones that were developed later on. For instance, polychlorinated compounds were at least less toxic to humans. Organophosphates were also less toxic to humans, and they were less persistent than the DDT and other compounds which already are in the environment nowadays. The pyrethroids are also considered to be less hazardous for the environment, and as I was mentioning, if the development of genetically engineering organisms that are supposed to be less toxic and persistent to the environment has been considered as an alternative. However, it is also true that in many cases the health problems are not known, although it is considered that should be less toxic to farmers. However, there is some also concern about the microbiological ecology related with these compounds. Also, there are some concerns about the monopoly of the products and so on. As an alternative, and the integrated pest management and the organic agriculture can be also considered as better for the farmers and also better for the environment. Okay, then after concluding this unit, I propose to you to do 4 exercises, and I also provide some complementary information that I'm sure will help you to do these exercises. In the first, list up to 20 pesticides and try to classify them by chemical group, but also by mode of action and by the non-toxicity to humans. As a second exercise, I would like you to focus on these 12 pesticides and identify all of them as for chemical group, mode of action, and also the effects on the environment. Ecotoxicology, that is the main issue in this course, and persistence, also important. Since we have been talking a lot about DDT over time, then I would also like you to do a bit of literature research and investigate whether or not is still used DDT worldwide and more specifically in Cambodia, and also if you can explain if it is still found in the environment, if it's still of concern from the point of view of the environment. Finally, since we have been also detailing some alternatives, some new developments that have recently or more recently been done, like for instance genetically engineered organisms, would like you to give an example of that and try to explain whether or not this is more or less toxic and persistent than organophosphates, for instance, and why. I recommend you 5 different readings, documents, and also some links to complete or to learn more about this unit. And I also added as a supplementary information to this unit the tables of classification of insecticides, herbicides, fungicides, and so on. Okay, then thank you very much, and we will see each other in the next session.